Alright, now let's look at this exercise 3. Okay, so now you have a plane wave. So you have a plane wave, okay, in a non-magnetic medium. Okay, the meaning of non-magnetic is the permeability, that is the mu r equals to 1. Okay, so this one belongs to non-magnetic mediums. Mu r equals to 1, has electric field equals to 50 sine 10 power 8 t plus 2z, and in the direction y. Okay, so find the direction of wave propagations, lambda, frequency, epsilon r, and also h. Okay, so these are the parameters that you need to find out. Okay, so let's look at the equations. Okay, so I will write down the electric field equation that is given by the questions. That is E equals to 50 sine 10 power 8 t plus 2z, and it is in the y directions. Okay, so what information that we can have? We know that this is the amplitude. Alright, this is the amplitude. Okay, so this is the E naught, the amplitude. Okay, so it is sinusoidal waveform, and over here is the omega. And this y is telling us that our electric field is in the y directions. And over here you have the beta. Okay, this is the beta, and the plus z is telling us that, okay, the directions of the wave propagation is negative z. Okay, remember, when it is positive z, means that the wave propagate in the negative z directions. Okay, so for the first question you can answer it easily, okay, whereby the direction of wave propagation is negative z. Okay, so you can write down, okay, wave propagate in negative z directions. Okay, wave propagate in negative z directions. Okay, we move on to the next question, that is the lambda. Okay, so we can relate the lambda, okay, with the beta. That is the propagation constants. Okay, no, sorry, this is the phase constant. Beta is the phase constant, and according to the equation, the value is 2. Okay, so we can relate the beta with the lambda by equations 2 pi over lambda. So if you want to know what is lambda, okay, you can take the 2 pi and divide with the beta. So in this case, 2 pi will divide with the 2. Beta is given by the questions. Okay, so you will get pi. Okay, so pi, or you write it as 3.142 meter. So this is the lambda. Okay, lambda given by the questions. Alright, we move on to the next one. Is the frequency, the F. Okay, so for the frequency, okay, you can find it by refer to the omega. Okay, omega in this case is 10 power 8. Okay, 10 power 8. Okay, 10 power 8. So omega equals to 2 pi f. Right, so your f will be equals to omega over 2 pi, which is 10 power 8 divide 2 pi. Okay, so let's calculate what is this answer. So it is 6.28. 6.28 times, oh, sorry, I pressed wrongly, sorry. So it's 10 power 8 divide 2 pi. Okay, so this is 15. 15.92 megahertz. Okay, so this is the operating frequency of this sinusoidal waveform. And lastly, okay, you need to find what is the epsilon r. Okay, epsilon r. Okay, so let's check what equation we can use. We know beta, right? So we could use the equations of beta. One thing when you want to select the equation of beta, because we have 4 mediums, right? Lossless, lossy, free space, and also the good conductor. Okay, we need to choose the suitable beta. Okay, so we need to identify what kind of medium is this. Okay, we know that the epsilon r is equals to 1, and if you realize that if you look at the amplitude over here, there is no attenuation constants. There is no attenuation constant. The attenuation constant I mean is the exponents, okay, alpha z. Okay, you don't have this term. Okay, when you don't have this term, this shows that this medium is a lossless medium. Lossless medium. So we flip back to our notes. So we can flip back to our note. We look at the types of medium that we have. Lossy, this is not lossy because we don't have the attenuation constants. The alpha should be 0. Okay, so this is not the lossy mediums. So when we go to lossless, okay, we go to lossless. Okay, lossless is with this characteristic. Okay, you don't have the attenuation constants. Okay, and your beta is represented by this omega multiply square root mu epsilon. Okay, so we'll be using this one. Okay, maybe you will be asking me why I don't want to choose the free space, because for free space the epsilon is equals to epsilon naught. Okay, so if this is free space, they won't ask you to find the epsilon r, right? So we are not going to use the equations of free space. We are going to use the equations for lossless medium. Beta equals to omega square root mu and epsilon. Okay, so we know our beta is equals to 2, omega is 10 power 8. So we have these mu naught, epsilon naught, and the mu r. Question say that it is 1. Okay, so we need to find out what is the epsilon r. Okay, epsilon r. Let's see how to do it. So is equals to 2 divide 10 power 8. Okay, so in order to remove the square root, we square both sides. So the epsilon r is equals to this one divide with epsilon naught and mu naught. Okay, so the epsilon r is equals to 35.6 Okay, 35.95. Okay, which is 36. Okay, 36. Right. Next, we move on to the magnetic field. They want us to find the magnetic field. So I'll write down again the electric field equations, which is 10 power 8 T plus 2Z, and in the directions of Y. Okay, right. So our magnetic field, okay, the H will be H naught. You have the amplitude, you must find out. Okay, sine 10 8T plus 2Z. For this section, it is the same, okay, for both the electric and magnetic field. Right, and the directions we need to define. So let's define the directions first. The directions. So we know the directions of the electric field cross with the directions of magnetic field will be equals to the directions of wave propagations. Okay, so the electric field is in the Y directions, and the directions of the H we have no idea, and the K is equals to negative Z, right? Negative Z. So negative Z. So the H, okay, directions will be X, right? X directions. So Y-X you get negative Z. Okay, so you could replace this one, okay, with X. The X directions. Now come to the term of H naught. So this one we need to use the intrinsic impedance because the E naught divided H naught is equals to the intrinsic impedance. So we can refer to the intrinsic impedance equations for lossless medium. Okay, so this one will be the equations because the conductivity is 0, so it's mu over epsilon. Okay, so let's find out mu over epsilon. Okay, so this one is mu over epsilon. Okay, so it's equals to mu naught. Okay, divide. Alright, just now we find the epsilon r, right? It's 35.95. 35.95 multi with the epsilon naught. Okay, so we can calculate this. And then square it. It is 62.83. Okay, without any angle because it's just a real number. Okay, it's not complex number. Right, so use this thing over here. So we have the amplitude of electric field, which is 50. So H naught equals to 62.83. So the H naught is equals to 50 over 62.83. So you have a 0.796. Alright. Okay, so this is the amplitude. So you can write, okay, your magnetic field as 0.796 sine 10 power 8 T plus 2 beta, and then the direction just now we say that it is X, right? X directions. Oh, this one's wrong. It should be Z. Okay, so this one will be your magnetic field equations. Okay, ampere per meter, the unit. Right. Let's check, is it correct? Okay, it's correct. Okay. Okay, so we look at now exercise 4. So we have a plane wave traveling in the positive y directions. So this is the K, in a lossy medium, you have to look at it. This one is a lossy mediums, okay, with the characteristic listed here, and this sigma represent the conductivity, okay, and the equation of the E is given, okay, but read properly. This E is only valid when the Y is equals to 0. Okay, now you have to find the E, okay, with the conditions Y equals to 1 and T equals to 2. Okay, so since this E equation is only valid when the Y is equals to 0, let us write down what will be the general equations for this E. So usually our E, we will have the amplitude, right? We will have amplitude, and in this case we will have the attenuation constants, because the question mentioned this is a lossy medium, so for lossy mediums, we will have attenuation constants. Okay, I put it negative alpha y. Okay, the alpha is the attenuation constants, negative alpha, because the question mentioned the plane wave is traveling in the positive y directions. If it is positive y, okay, over here I will write negative y. Okay, so cos omega has been given 9 pi t. Okay, this one is the same. Okay, and usually we will have beta, right, the phase constants. Okay, with this is the directions of the propagations, and in the questions we see there is a pi over 4 or a phase. So here in fact we will have a pi over 4, and in the z directions. Okay, when the y is equals to 0, what we can see is when the y equals to 0, these terms will gone. Okay, this term over here will gone, will become 1. Okay, and this term also will gone, because we have the y equals to 0. Okay, so it left the equation which is exactly like this one. Okay, so the general equation is this. Okay, so before we able to find the E at the position y equals to 1 and t equals to 2 nanosecond, we need to find out what is the alpha and beta. What is the alpha and beta, because we need these two values. Okay, so this is a lossy medium, so we will be using the alpha and beta equations, okay, in the lossy mediums, which is omega square root. Okay, so I have mu epsilon over 2, and then I have 1 plus sigma divide omega epsilon and square, and over here is a square root minus 1. So this one will be the equations. So let's replace the value. 10 power 9 pi. Okay, 10 power 9 pi. And then we have the mu naught, epsilon naught. Okay, and the epsilon r is 4. We'll divide with the 2. Okay, and 1 plus sigma is 10 power negative 2 over omega is 10 power 9 pi epsilon naught and 4. Okay, you have a big square, and then over here you have a square root. So please write it properly, otherwise you will calculate it wrong. Okay, so the calculation is very straightforward, but make sure you write it correctly. Okay, you write it correctly. Okay, so we can, I think I will straight away calculate it. So we can straight away calculate this thing. Okay, alright, maybe I will calculate because later on for the beta I need the same thing also, so I will calculate part by part. So this one is 10 power 9 pi. Okay, so over here I have So this is 2.22 times 10 power negative 17. Okay, so inside here I got 1 minus. So over here I will have 1.004 minus 1. Okay, so the answer will be okay 0.936. This is my alpha. And for the beta, okay, so the equation of the beta is very similar to the alpha, okay, except this term, right? Okay, for beta it will be plus. So I will just write the value. Okay, so it will be 1.004 plus 1. Okay, so plus 1. So you find your answer equals to 20.95. Okay, so you get these two value. So now you can replace them over here. Okay, over here. Okay, so y will be going to replace by 1 and t is going to be replaced by 2 nano. Okay, so let's do it. Okay, write down. The E is equals to 30. So exponent negative 0.3936. The Y is equals to 1. Then I have cos 10 power 9 pi, and the T is equals to 2 nano. 2 nano. Minus beta is 20.95. The Y is equals to 1. Okay, and plus pi over 4. And the direction is Z. Okay, direction is Z. So here I need you to take notes. So for this term, when you want to press for this term, you must make sure that you change to radian. Must make sure that your calculator is in the radian mode. Okay, in the radian mode. Okay, so you can calculate part by part. So this one is 11.77 and cos is a negative 13.88. Okay, the Z directions. So this one is radian. Radians. Radian. Make sure you press in radian. Okay, so you have a 0.254. So it's 2.994. Okay, Z directions. And watt per meter. Okay, so this one is the electric field. Okay, electric field when the y equals to 1 and the time equals to 2 nanosecond. Go to the next questions. The distance travel. Okay, how far the distance traveled by the wave to have a phase shift of 10 degree. To have a phase shift of 10 degree. Okay. So from the equation of beta, okay, this is the phase constants. Okay, so we know that, okay, the wave will experience 2 pi. Okay, 2 pi of phase shift when it travels, okay, in a distance of lambda. So now they are asking you, okay, how much distance, okay, how much distance that has been traveled if the phase now is 10 degree. Yeah, the phase 10 degree. Okay, so we have to convert this 10 to radians, okay, to use these equations. So we convert to radians. So to convert to radians, okay, 10 multiply pi over 180. Okay, so you will have a pi over 18. So when you put this thing here, it's telling you you want to find the lambda, the distance travel, okay, when your wave has a 10 degree of phase shift. Okay, so the beta here, you can use the beta that we find earlier, 20.95. Okay, 20.95. So the lambda is equals to, it's easy, can get 8.33 millimeter. Okay, so this 8.33 millimeter is telling you that, okay, the wave, after it has a phase shift of 10 degree, it will travel, okay, 8.33 millimeter. Okay, or in other words, after the wave travel for 8.33 millimeter, it will have a 10 degrees of phase shift. This is the meaning. Okay, we look at the next one. Next one is that asking you, distance travel by the wave, okay, do have its amplitude reduced by 40%. So how much distance that the wave travel, okay, to have its amplitude reduced by 40%, reduce sebanyak 40%. Okay, so reduce sebanyak 40% means that, you see, this is your equations, right? This is your equations. So the amplitude of your electric field is actually 30, but after it propagate for some distance, if you remember, this one is a distance, right? So the amplitude will drop. Drop sebanyak 40%. It means that it's still left 60%. Okay, still left 60%. So here I will write it. Okay, so the amplitude is equals to 30 multiply exponent negative 0.936y. Okay, so when the amplitude drop by 40%, it means that it's still left 60%, right? So how much is 60%? You can find out how much is 60%. 16% means that it's still left 18 volt. Okay, so still left 18 volts. So you want to know how much distance, okay, that is the y, will make your amplitude drop until you get 18. Okay, so this one is 18 divide 30, right? So you will have an exponent negative 0.936y. Okay, next one, you will have a 0.6, right? So if you want to solve for this one, you have to ln it, ln 0.6. When you ln the left side, you have to ln the right side. Okay, we use ln because when we apply the ln later on, this thing you can bring forward. Okay, you can bring forward. So press calculator, you get negative 0.511. So we can calculate your y, right? You can calculate y now. .54 6 meter. So after the wave travel for 0.546 meter, then its amplitude will become 18. Amplitude, okay? Amplitude will become 18. Right. Okay, we look at the last one. Okay, you need to find y is the h. Okay, at y equals to 2 and t equals to 2 nanosecond. Okay, h is not given. H is not given, so you need to find the h. So let's write down the equations for the h. Just now, this one is A, B, this one is C, right? C. And let's find the D, the equation of the H, magnetic field. So magnetic field, it has its amplitude. Okay, so the attenuation constant is the same. Okay, so you have a cos 10 power 9 pi t minus the beta is how much? 20.95 y plus pi over 4. It's the same thing, you just write. And the direction, you have no idea the directions. Okay, so you need to find out. So let's find the direction first. We find the direction first. Okay, so the directions, the direction is equals to E direction cross with the H. Then you get the K. Okay, so the E direction is Z. H you have no idea, and the K is equals to Y. Okay, so obviously it will be Z X Y, right? So your direction of H will be equals to X direction. So you could replace it with X directions. Okay, next one is about the amplitude. Okay, so amplitude, we have to use this relationship. Okay, so meaning that we need to find the eta. This is the eta, the intrinsic impedance now. Okay, so the intrinsic impedance is equal to J omega mu divide conductivity plus J omega epsilon and square root. Okay, and square root. Okay, we try to replace the value. J omega is 10 power 9 pi, and this is mu naught only, right? And over here you have 10 negative 2 plus J 10 power 9 pi epsilon naught and 4. 4. Okay, so change the mode of a calculator to complex. Change to complex mode. Change to complex mode, and then make sure that there is a symbols of angle. Symbols of angle at the top of your calculator. Angle. Because you want the answer, okay, to be written in polar form, for you to do the square root later on. Okay, so you can get answer equals to 35422.7, and the angle can be radian and also can be degree. So here I use degree. Okay, this is the answer. So this one you do it manually, okay, like we did in the class. So you will use the calculator to calculate. Don't use the complex form to calculate this one. Okay, it's not able to do it. Okay, so for the angle is 5.15, you have to divide 2. So this is the way of doing it. So you get 188.21, and the angle is 2.575 degree. So this is the intrinsic impedance. So after getting this intrinsic impedance, we are going to replace it over here. So I will do it here. So the amplitude of the electric field is 30 H, you need to find out, and the intrinsic impedance is 21 over 2.575. Okay, the reading. So the H naught will be equals to multiply divide 0.16 minus 2.575. Why minus? Because this one the angle is 0. 0 minus this one become negative lah. So you have this one. Or you can write it as 1/6 exponent negative j 2.575. This is degree. If you want to convert it to radian, because later on this one is radian, right? If you want to convert it to radians, okay, you can change it. You can make it to be 0.16 exponent negative j radian. Convert to radian, 2.575 times pi over 180. So 0.045, things like that. Okay, so now replace it here. Okay, you can replace it here. So I will move this thing a bit. Okay, so you have this is equals to 0.16 exponent negative j 0.045. Okay, so this 0.045 you can bring it inside. Okay, so it is a negative 0.045 plus pi over 4. Okay, so you could write it as, I will write down here. H equals to 0.16 exponent negative 0.936 y cos 10 power 9 pi t plus 20.95 y and plus 0.74, and in the x directions. So when the y is equals to 2, and the t is equals to 2 nano, okay, so now you can replace 0.16 exponents. Okay, so I will directly write it as 1.872. Okay, cos 10 by t is 2 nano. Okay, plus 20.95. This is 2. Okay, and plus 0.74. This is x. Okay, so here you will get 0.025 and cos negative 34.88. 34.88. Then you get your answer, negative 0.024 in the x directions, and the unit is ampere per meter. So this is your H. Oops. Okay. The answer is not the same. Right, I calculate again this one. The angle is different. Wait, let's check whether we can get better answer or not. So this one is 35338 or 339, easy. 339, and the angle is 0.09. Okay, 0.09 divide 2. Okay, let me try again. Square root. So 187. The difference is just a bit. 188. Just put 188. Easy. Zero point 045. Just a little bit difference only. Okay, so over here is the same also. Same things also. So I can directly replace it with the angle is okay, it's the same thing. Calculate again. Here is minus, minus, right? Minus. Let me try again. So if this is minus, $47. So it equals to negative 23.7 milli. Okay, 23.7. This is the correct answer. Alright, we look at this practice exercise in your module. Okay, so we have an electromagnetic wave propagate in the positive z directions. Okay, so positive z, okay, is the directions of wave propagate, okay, through a lossless medium. Okay, so this lossless medium has a characteristic of this. Okay, so for lossless mediums, okay, the conductivity is equals to 0. Okay, so it is characterized by an electric field defined by this. Okay, so this one, okay, represent the amplitude. Okay, and this one, no, not amplitude, is represent the equations, equation of the electric field, and this one is representing the directions of the electric field, which is in the x directions. So question telling us that the frequency is 1 gigahertz and the maximum value of 10 volt per meter when the position is 0, when the t is 0 and the position z is equal to 0. Okay, so we have to find the expressions, the equation for the electric field and also the magnetic field. Okay, so first of all, let's look at the general equation of electric field. So what is the general equations? Okay, so for electric field, we will have an amplitude, right? since this one is a lossless medium, so we won't have the attenuation constant, okay, the exponent, we won't have this one, okay. So it could be cos signal or sinusoidal signal. So here I will just use the cos, okay. Can be sine also, nothing is wrong because here don't have any specific requirement saying that whether the signal should be cos or sine. So we will have the omega t. Okay, so the wave propagate in the positive z directions. So positive z direction will give us the negative beta z, okay, negative beta z, and the direction of the electric field is x, okay. Whereas for the magnetic field, okay, the general equation will be the amplitude also H naught, and you have a cos omega t minus beta z, okay. So the direction of the magnetic field you can determine, you have to determine it, okay. So what is the component that we need to find out? Of course, okay, here already tell us that, okay, the amplitude is equals to 10 when the t is 0 and the z is 0. Okay, what happened when the t is 0? T is 0 will give this one 0. Okay, z0 will give this one 0. So it is cos 0. Cos 0 is equals to 1. Okay, so this 10 volt actually represent the amplitude of the electric field, Okay, so this one we can recall it. Okay, so this thing is going to be 10. Okay, it's going to be 10. Right. Okay, omega, you can determine it by using the equation 2 pi f. Alright. And beta, you can also find out for lossless medium, what is the beta? Okay, so we can flip back to our notes here. Oops. So here maybe we'll look back to our PowerPoint slide. We look at for the lossless mediums, what will be the beta? So this is lossy. Okay, so for lossless, the beta is equals to omega square root mu epsilon. Okay, omega square root mu epsilon. Alright. Okay, and this one you can find out, right, by using these equations. And for this, okay, you can find out by using these equations. Okay, equals to eta. So this tells us that we have to find the eta. So the eta for lossless will be square root mu over epsilon. The eta is equals to square root mu over epsilon. So we need to find out, okay, before we could get the equation for the electric field and also the magnetic field. So the first thing I want to calculate would be the omega, okay, equals to 2 pi f, okay. So 2 pi multiply with the frequency 1 gigahertz, 1 gig, okay, 1 gigahertz. So it is equals to 2 gig pi, okay, 2 gig pi means 2 multiply 10 power 9 pi. This is the omega. Then we have the beta. Okay, so the beta will be omega and square root mu naught epsilon naught. Okay, look at the information from the questions. Okay, it is 4 and 1. Okay, 4 and 1. So we replace the 4 over here. Okay, so omega we can take from here. Okay, so 2 power 9 multiply square root shift constant. Okay, multiply 4. Okay, so we will get 13.34. Okay, 13.34. Oh, forget the pi. Okay, sorry, this one. Forget to include the pi. 2 times 9 times pi times square root, shape constant 1, 4, 5 times 4. Yes, it's a 41. 41, 41.92, 41.92. Okay, 41.92. Okay, what else? Okay, let's find the eta. So the eta is equals to mu naught, okay, divide epsilon naught and 4 and square root. So we have a square root. So it's equals to 188.4 is a real number. Okay, and then now we can find out what is the H naught. That is the amplitude. The amplitude of the magnetic field, it is equals to 188.4. So the E naught just now it is 10, right? Okay, so the H naught will be 10 divide 188.4 is a 0.053. This one is the amplitude. As for the directions, okay, we are going to find out where is the directions. So the E is in the X directions, and the H you don't know, and the K is in the Z directions. Z directions. So the H will be X, Y, Z, so in the Y directions. Okay, now you got everything, so you can put them inside the equations. Okay, so the equation for the E will be 10 cos, okay, it is 2 times 10 power 9 pi t Alright, so this one will be negative. Beta is 41.92. 41.92. And the direction is Z directions. Okay, and the electric field is X directions. Okay, so this is the electric field. As for the magnetic field, the amplitude will be 0.053 cos 2 times 10 power 9 pi t minus 41.92 Z, and the direction is Y directions. Okay, so these are the electric and magnetic field. Let's check the answer. 10 over 60 pi. Yes, is 0.053. So this is the correct answer for these questions.